Hello class, welcome to lesson 8.1a, which is all about probability and simple events. By the end of this lesson, you should be able to find the probability of a simple event. Something that I want to make sure that you have written down somewhere is this right here. So we have the probability of an event happening, so P stands for probability, the probability of an event, so whatever I specify, equals the number of favorable outcomes, so what I want to happen, over the possible outcomes, okay? What you want to happen over the total possible outcomes. So make sure you pause the video, give yourself time to copy that down, and let's jump into our first example. So let's use a number cube to find the probability of each event. FYI, the book refers to dice as number cubes. So we're just talking about a normal dice that we've been using like when we play Monopoly or something. Okay, so write as a fraction in simplest form, a decimal, and a percent. Okay, so that means we are going to have 3 different answers for each one. Okay, so what's the probability of an odd number? Well, let's think about it. If we have a dice, we can roll a 1. We could roll a 2, we could roll a 3, we could roll a 4, a 5, or a 6. So if we want odd numbers, right, over the total possible. So how many odd numbers are there? There's 1, 2, 3, and there's 6 possible outcomes. So there's our fraction, but we want it in simplest form. So our fraction becomes 1/2, which as a decimal is what? 0.5. And as a percent, 0.5 as a percent is 50%. Okay, so we're tying together some old skills here. What about the probability of rolling a 5 or a 6? So again, we want to list the possible number of outcomes. So we want 5 or 6 over total. In this instance, that's 2 possible outcomes because we want a 5 or a 6. That's 2 out of the 6, which if you reduce 2 6 to a fraction in simplest form, that becomes 1/3, which as a decimal, 0.3, repeating. Or you could say 33.3 repeating percent. Alright, so we're practicing some more skills with decimals, writing them as fractions, writing them as percents, okay? And let's look at our last one. What's the likelihood of it being a prime number? So a prime number we haven't talked about a lot, but a prime number is any number that doesn't have other numbers that multiply to it. So we could have a 1. So we have 1. Another prime number could be what? 2, 3. Does 4 work? 2 times 2 gives us 4, so we know 4 is not prime. What about 5? 5 is 1 times 5, that's it. So that is prime. And 6, you could write as 2 times 3. Now when you're working with prime numbers, they actually don't include the number 1 in prime numbers. So that means we have 2, 3, and 5. So we have prime number over total. And we said that that could be a 2, 3, or 5, so that's 3 possible options over 6, which is 1/2, which we already said was 0.5 as a decimal, or 50% as a percent. Okay? So remember, it's always what you want to happen over the total number of possible outcomes. Let's look at our second example. We have the table that shows the numbers of brass instrument players in the New York Philharmonic Suppose one brass instrument player is randomly selected to be a featured performer. Find the probability of each event, write as a fraction in simplest form. So, what's the probability that that one selected person is a trumpet player? Well, let's look. How many people do we have total? We have 6 horn people, 4 trombones, so that's 10, plus 3 trumpet, that brings us up to 13, plus 1 tuba. So we know we have a total of 14 people in the brass section. So what's the probability that it is a trumpet player? Well, there are 3 trumpet players out of a total of 14. So we say 3 over 14. Is that as reduced as it can be as a fraction? Yes, so we are actually done with the probability of it being a trumpet player. That's all you would have to do. What about letter E? What's the probability of it being a brass instrument? Well, let's think about this problem. We're talking about the number of brass instruments. So the number of brass instruments. That means these are all brass instruments, so 14 out of 14, because we want a brass player. We have 14 of them. There's a total of 14. So 14 over 14 as a reduced fraction is just the number 1. What about the probability of a flute player? Okay, so how many flute players do we have? We have 0 out of 14 total players. That means the probability of there being a flute player selected is 0. What if we were talking about a horn or a tuba player? So now we have horn or tuba, so that's 6 plus 1 out of the 14. So that's 7 over 14, or reduced is 1/2. Okay, so it's always what you want, the number of what you want, over the total. Let's look at our third and final example. Ricardo's teacher uses a spinner similar to the one shown to the right to determine the order in which each group will make its presentation. Use the spinner to find the probability and write as a fraction in simplest form. Okay, so what's the probability of it not being group 4? What's the probability of it not being group 4? Well, how many groups do we have? What's our total? We have 6 groups. And how many group 4s do we have? We have 1, so we can take our 6 groups minus the 1 group, because we only have 1 group 4, right? So this becomes, there's 5 groups that are not group 4 out of 6. Is that as simplified as a fraction as possible? Yes. What about our last one? What if we don't want group 1 or group 3 to go first? Well, let's see. We have still a total of 6 groups, and we have 6 groups minus, we're to take 2 of them out. That means we have 6 minus 2. That leaves us with 4 possible groups left out of the 6. Reduce 4 over 6 as a reduced fraction becomes 2 over 3. Okay. So hopefully this isn't too terribly difficult for you. But if you have questions, please let me know. I would be happy to help when I get back, or feel free to email me. And yeah, have a great day. See you guys tomorrow.